Hello, my name is Bill Craig from Avid Systems. Thanks for checking out this video on interfacing the AVS-4000 software-defined radio to GPSD. Since you're checking out this video, you're probably already familiar with both the AVS-4000 SDR and GPSD. So if you think this is an awesome capability, keep watching. We'll show you how simple it is to interface GPSD to the AVS-4000. The AVS-4000 has an integrated GPS receiver and is using GPS to timestamp received data and to synchronously start and stop radios that are not geographically co-located. This capability is used to geolocate emitters, create RF heat maps, as well as a host of other applications. GPSD is a Linux Software Service Daemon that can process NMEA data from one or more GPS devices over a serial interface. Applications interface to GPSD over a TCP socket, so remoting this data over Ethernet is easy. Some applications that use GPSD are Google Earth, XGPS, GPSmon, and GPS Logger. The AVS-4000 is controlled by the AVS-4000 Daemon. It can be launched in either device manager mode or device controller mode. Once all of the AVS-4000 radios have been discovered and programmed, the Daemon opens a pseudo terminal and places position, velocity, and timing data into that terminal so that it can be accessed by GPSD. GPSD then makes this data available on a TCP port so that other applications such as Google Earth can access it. For this demo, a GPS antenna needs to be connected to the GPS MMCX connector on the rear panel of the radio. The AVS-4000 has an integrated bias T and outputs 3.3 volts so that it can power an active GPS antenna. Here's the setup for this demo. I'm using Ubuntu 22.04. I have a GPS antenna connected to the radio and the USB 3.0 cable that provides command and control for the radio. I don't have anything connected to the 2 MHz to 6 GHz receiver or transmitter SMAs on the front panel since they're not necessary for this demo. To get started, let's pull up a terminal window and take a look at where the pseudo terminals are held on the Linux system. In the /dev/pts directory, we see that the system is currently using 3 pseudo terminals. So if we launch the AVS-4000 daemon, we would expect that the 4th pseudo terminal would show up in this directory. So let's give that a shot. Okay, the AVS-4000 daemon has programmed up the radios that it has found connected to it, and we should be able to check the /dev/pts directory. Okay, and we have found the new pseudo terminal number 1 here. So if we just cat that file, we see that the AVS-4000 daemon is indeed putting GPS data in NMEA format into that pseudo terminal. So the next thing to do is, we can stop that. We'll go ahead and install GPSD and try and connect it to this pseudo terminal. Okay, to install GPSD, the first thing we're going to want to do is update the system packages. Do an update. And once we're done with that, then we're going to use this command to install GPSD. Okay, now that that's done, we'll need to give GPSD the proper permissions to be able to access the /dev/pts directory. Okay, to do that, we're going to edit this file here in the etc apparmor.d directory. And we're going to edit the serial. We're going to go down to the common serial ports. Right here, and we'll enter in the following line. This will provide GPSD with access to the pseudo terminal 0 through 9. So we'll save that. And then we will restart the AppArmor application using this command. And GPSD should be ready to roll and read NMEA data out of pseudo terminal 1. So to test that out, we'll use the following. So we're going to launch GPSD in debug level 5 mode, and we're going to launch it in the foreground, and we're going to be using data out of the pseudo terminal 1 file. And you can see GPSD is reading the NMEA data from the pseudo terminal. So now we've connected the radio and its internal GPS receiver to GPSD. So this navigational data is now available over the network to other GPS clients. So before we use this with other GPS clients, we have to install something called GPS clients. So I'm going to stop GPSD here, and we can install GPS clients with the following command. So yes. Okay, and so now we've installed the GPS clients package from Linux, and one of the first GPS clients we'll try is XGPS. So to run XGPS, we're going to need to start GPSD back up again. So we'll run GPSD, and we will run it in daemon mode this time, /dev/pts/1. So we've got that running. Now just simply type in XGPS. So once you launch XGPS, you will then see a window pop up that looks like this. XGPS here is displaying all of the GPS satellites that it sees and which ones it is using in its position and timing calculations. All the way to the left under satellite list, it is giving you a list of all of the US-based GPS satellites it sees. They're labeled GP. All the Russian GPS systems, which is the GLONASS constellation, is listed as GL. The SB is a satellite-based augmentation system that's augmenting the data that you're receiving from the US-based GPS system. At the bottom here, it gives you a summary. So that's XGPS. So next, let's take a look at Google Earth. In order to use Google Earth, we'll first have to download the Debian package for Google Earth Pro. Once we've downloaded the Debian package, then we go ahead and install it. And now Google Earth is installed. In order to demonstrate Google Earth, we will need to generate a KML file. A KML file stores the geographic data from GPSD so that it can be displayed in Google Earth. Earlier, we installed something called GPSD client. In GPSD client, you see that there is an application called GeGPS. GeGPS takes the data from GPSD and removes just the geographic part of it, and then formats that data so it can be read into Google Earth. From a terminal window, we will launch GeGPS with the -D option, followed by a tilde, which tells GeGPS to place the KML file into the home directory. And go ahead and launch that. Before we launch Google Earth, I just want to summarize what we've done here. The AVS-4000 SDR is providing GPS data that is sent to a pseudo terminal in the /dev/pts directory. GPSD reads that data from the pseudo terminal and makes that data available on a TCP port. We've now launched another client called GeGPS to extract just the geographical data and format that data so that it can be read into Google Earth. Let's pull up another terminal window and launch Google Earth. That's the command to launch Google Earth. Okay, after launching Google Earth Pro, we'll be presented with the Google Earth Pro GUI. The next step is to open the KML file that was produced by GE GPS, which should be in our home directory. So if we do File Open, we'll see that we have something called realtime_GPS KML, and we'll just select that and open it. And once we open that file, Google Earth then starts to zoom in on our position. A little too close, we'll need to back that up a bit. And we'll exit ground level view. And we'll see that Google Earth has positioned us correctly. That is the position of the Avid Systems office space. So that about wraps up the demonstration of using GPSD with the AVS-4000. I'd like to thank you for watching. If you have any comments or questions, please email me at info@avid-systems.com. Thank you very much.